All right, so we have been talking about de-ice is where we left off yesterday. Right there. In fact, now that I started this, I'm wondering who's got the thickest notebook in here.
I got two.
You went to two? All right. All right, so we talked about anti-ice, and what was the anti-ice system?
Anti is the chemical formation of ice.
Chemical prevents the formation of ice propellers. Now we're talking about de-icing. Let's see, accomplished by the use of heated boots bonded to the prop, and as the boots heat up, ice is melted. At the surface, and by surface I mean the ice to propeller surface, not the outside. So at the surface, and thrown off by centrifugal force. Now this brings up the question, why is this de-ice and not anti-ice? I mean, couldn't I just turn it on if I expected to enter icing conditions and just run it as a preemptive measure?
No. You have to have ice build up or anything.
Why?
Block it off.
Why?
Because if you're just running it, you can get like you were saying yesterday, like a bubble of ice around the boots, like the ice.
Well, these boots can inflate?
On the props? No.
No. So what if I turn it on and make the props 100 degrees Fahrenheit? Is ice going to form on it? So why not just turn it on? Okay, so we got load on an alternator. What's that going to translate into? It takes a little bit of power. Then fuel economy goes down. So I know it's what fuel economy? Boy, I'm just ripping them off the prop now. What else?
I don't know, it might overheat and then you won't have it available once you need it.
There we go. Okay, when you're in aviation long enough, you're going to hear stories, and it usually revolves around windshields, but it also involves these. During an annual or phase inspection, depending on the aircraft, you do have to test this stuff. And so the way you test propellers make sure that the de-ice works is you have somebody go in the cockpit and you turn it on and you go out there. The prop is not running. Anyone might note this. And you feel the prop is not running.
No. So when I was reading it in the Q&A, I was like, son of a bitch, how are you going to test that when the prop's running?
It's a McDonald's app. At least he thought of it, though. So anyway, so you feel, and I'll show you its sequence. You're going to feel each section to get hot. As soon as it gets hot and you can feel it, one cycle, you shut it down. You don't keep running it. Now, windshields also have, a lot of windshields have very fine wires running through them that heat up and get the windshield. Well, you're sitting on the ground and you're not in icing condition. You turn on the heated windshield, it eventually starts to bubble and boil the plastic. And then you come in the next morning like, somebody forget to turn off the windshield heat. And that's okay because, oh man, it's been 20 years ago. My friend's dad worked for Delta, and somebody did that to one of the aircraft, and it was not a big deal. They just had to get a new window section. So 20 years ago, the half window, anybody want to guess what that section cost?
Wait, what's that?
$40,000.
10,000? 10,000?
50.
I was asking for like 40.
Yeah. Front of a, I don't know, 727 probably back then. So, huh?
What year was this?
20 years ago.
Yeah, in that money.
Yeah. All right. So that's why I say it's de-ice, or the book says, because Juan, you have this on your airplane, and is that pretty accurate? You don't turn it on unless it's very cold.
Well, when you're going to icing, I always turn them on because it's cold enough.
It's cold, yeah.
But the problem is you don't use them on the ground or anything like that.
Yeah. So it wouldn't be like, okay, so I explained how with the inflatable boots, how it actually could be a problem if the boots are inflating and the ice kind of works its way around an inflated boot. And when the boot inflates, it's never going to actually puss the ice off. So you don't have that problem with this. You just have a problem with melting the glue in the pads. All right, so operation. So they're electrically heated when the system is turned on. Current travels from the control unit to a brush block that rides on a rotating slip ring. And I was hoping this had a picture of that. It does not. All right, so to explain rotating, obviously you can't have a solid wire going from the aircraft to a rotating propeller because you would need a lot of wire and it would wind up around the prop hub and get all tight, right? So, okay, so you've got to have some sort of connection that allows it to transfer. Well, you guys have had generators, alternators, so you understand slip rings and brushes, right? Please say yes, okay. So if you haven't had electricity, over on this side, so a brush block is like it's a piece of carbon. So you'd have actually 3 of them, and you have carbon blocks. The electricity comes up to the carbon block, and it touches something that's rotating in tracks. So it just has 3 little tracks, and that rotates. And so it transfers from the carbon blocks to the piece that's rotating, and the electricity then goes from wires to the boot. 2, power is sent from the brush block through the slip rings to the propeller. Power is sent from the brush block through the slip ring to the prop. So now we get to the prop. Well, what's the prop got? Well, the prop has, the blades have a bonded heating element. The blades have a bonded, what does bonded mean? All right. Bonded heating element that heats with current flow. Now, if this was 1985, I would say just like a waterbed heater. You'd be like, oh, I got it.
I know what that is. Basically like a little resistor, isn't it?
Yeah, this is the resistor strips. They get hot. All right, because the heating element draws a lot of current, because the heating element draws a lot of current, there is a sequencer and a sequencer is something that makes things in sequence. It's not like a sequencer, you know, like bedazzled something.
The filaments that are in the windshield, are they large enough to see when you're flying, or are they
Huh?
invisible?
Your eye doesn't pick them up unless you're looking for them. So if you focus on it, you'll see them. Otherwise, you don't.
So it's not like in the car in the rear.
No, it's not that. It's not that. That's why they're so expensive. There is a sequencer. Where was I here? To heat only one. Oh, there's a sequencer to heat only one section at a time. All right, so I'll throw in an example. So the example, example. So I'm used to having this up at the same time. Maybe we can do it this way. So example, let's see here. I got a pin. We got phase 1. Well, this will work. So got a twin engine, so this be the left, that's the right. So we go left engine outboard. So left engine outboard would be 1. And then 1 second null, then left engine inboard, 2. 1 second null, right engine outboard. Oops. 1, 2, 3, 3, 4, 4, like that. Make sense, hopefully? And I think that depicts it here somewhere. I can't see which one's on. Oh, this one's on. That is 1 and 2. Anyway, drawing's a little bit different than what I said, but it would work just like that. Let me write that. So, example, left engine outboard. And then you have a 1 second null period. What's that mean?
0.
Nothing, it's off. So outboard, then a second off. Then left engine inboard. Second null. Then right engine outboard. 1 second null. And then, oops, right engine inboard. 1 second null.
That's the interval
Yeah.
for each heating factor.
Only one section at a time?
Because the heating element draws a lot of current, and so it'd be too much current to do them all at the same time. You need a much bigger alternator if you're going to do that.
So how hot are these getting within a 1 second?
Null means off.
So how long are they on?
Well, hang on, I'll tell you. Yes.
So, would it be the same reason why we can't run all 4 outboards at the same time, as you were just explaining to him?
Yes. It's sequenced because if you try to turn all sections, so it's sectioned, right? We could just do it in one section. It just all are on, and every single blade has got a section, and just turn them on, and boom, they're all on. They're all on. But it's way too many amps, and you don't need to do that. So, yeah.
Left engine outboard, 1 second null. Does that mean
Off.
all of them are null?
Yep. Yep. Okay, so if I go back to here.
So basically the left engine outboard is on, and then it's actually 1, 2, 3, 4, 5, 6, 7, 8, 9 times off until it comes on again.
Well, let's look at this right here. You can actually see it's 4 times off. So each one of these spaces right here represents an off period. So here we have, okay, so our brush block, this one's going where? Ground. Okay, so here we come. So this one is connected to here. This one's connected to here. That one's there. That one's there. So we need a path. So during this period right here, we'll say power comes this way, up through this brush block, through this slip ring. This slip ring is connected to here, which comes down to here and heats this one up. There's the return path, comes through here, goes to here, and back to ground. Got it?
Got it.
Okay, so this sequencer moves around. So in just a little bit, as it's traveling around, pretty soon it's going to be right here.
It's basically like your magneto.
Sure, it's like a magneto. What do you call it? The distributor finger.
Mm-hmm.
Okay, so this, oops, don't do that. So this one's going to come around here and heat this one up. And it's got a return path back to ground. Right? And so then it's going to come over here, and that's going to do this one, come over here, and then it's going to do this one. Follow? Okay, so every space in between here is 1 second off. So that's your null period as it travels around. Yes.
Sorry, what do you mean by engine outboard and inboard?
Okay, so this is out. This is in.
It's kind of a prop.
Okay.
You have an outer part of your prop and an inner part of your prop.
Yeah.
Okay, gotcha.
How many segments can a stator be, like, go up to?
What do you mean?
Like the part that receives the pulse from the, well, not the pulse, but the current from the sequencer.
Oh, how many of these?
Like, if you have 3 bladed props, would you have 6 segments?
Now, I've never seen more than, I don't know.
Okay.
You can go infinity if you can fit them in there. There's no rule of thumb that says you have a minimum and you must have a maximum.
I mean, how many? It's always inboard and outboard. And then on a
I never say always.
Okay.
I have never seen more than 3 slip rings on a prop. So that tells me that, well, if you add one more prop, then you're going to add one more segment, but that still means inboard outboard, and no more than inboard outboard, because every time you add another one of these, you have to have another slip ring now, and then you get a bunch of slip rings going, and then you got to change, and then you can add. So you can keep adding them as much as you want. It's up to whoever decides to do it. All right. So each, I was going to say something. Each element is heated for about 15 to 30 seconds. And let me see. Boots can come delaminated. What does that mean?
Comes off.
Comes off, the glue gets soft. Delaminated if they overheat. So don't just turn it on just because. And make sure, like I said, during an annual inspection, it's a big deal. Whoever's in the, it took 2 brains to do this. One, would never turn it on and then walk out and feel the prop and then go, okay, and walk back around, turn it off. I would always have somebody else in the cockpit and I would be outside or vice versa. And it's always somebody who I really trusted because I wanted to make sure it was off. So they say, okay, turn it on. They turn it on, prop on. And I'm going to show you, they're going to start watching the ammeter too. And the prop ice the indicator, if it has one, and you're going to be feeling the blades, and you'll be talking to each other. Okay, null period off, next one's on, you find it, next one on, and then when you're done, then you'll say, okay, prop off. And they say prop off. You say master's off, master's off. Okay, we're good.
How would you check, what would you do during a pre-flight computer? Like for a pilot, is there something that you'd have to check for that?
I guess you could do. I know the answer. You watch the indicator. So you turn it on. There's an indicator in the cockpit. You see the current draw.
You have a dedicated ammeter.
Yeah, that's what I'll show them in a minute. So, all right, let's see.
Would there be an indicator for an overheat?
What's that? No, there's no indicator for an overheat because that would require another slip ring. You'd have to put a temperature monitor on it, on each section, and then run it through slip rings, and then you would get an overheat, but you wouldn't know which one it was, and then what are you going to do about it? If you're flying in icing conditions, you get overheat, well, you can turn it down. All right, operational modes. Operational modes may include, well, should be a subheading, but whatever. Full ice or full de-ice. We'll put full de-ice. Spring loaded to off switch that must be held on. So spring loaded to off. That must be held on. And this overrides the sequencer and heats all blades at the same time. Why would I want something like that? All right, you just woke up from your nap. Plane's been on autopilot. You look out. You're headed down. You got ice built up all over the wings. You're like, oops. All right, so you take this thing, and you have to hold it. You have to manually hold it, but you hold it on, and it's going to heat all of the blades at once. That's going to draw a lot of amps and heat them all up and get rid of the ice, and then you're going to go into a different cycle. So full de-ice. We have fast cycle. And we can say slow cycle. And what that is going to do is tell you how fast this little pointer is going to go around. So fast cycle is going to go around fast. Slow cycle is going to go around slow. And I feel like I'm missing a page.
Do you use fast for a lot of ice or slow for a lot of ice?
I know. That's kind of a funny thing. I was just thinking about that myself. Not being a pilot. Juan, what do you say? I would say fast for most ice, so it's heating them constantly. Not a chance to cool down.
My system is a lot simpler. You know, just you turn it on and it has 90 seconds on, 90 seconds off for the 3 blades. And it has to be on the green arc for the emitter. If it's not a green arc, it means that is heating unevenly and you need to switch it off.
Okay, so slip ring is going to be back behind starter ring gear support. So these wires are going to be spinning around with the prop. You have 3 wires, 2 segments, inboard, outboard. And here's these are just ammeters set up. So you can see how many amps it's drawing, or high-low amps. Got it? So as a pre-flight, you could just look at this. It's going to click on, click off. So pilot comes to you and says, hey, I got a problem with my de-ice system. Well, what's your problem? Well, as I'm watching it, I turn it on and it won't stay on. Keeps cycling off. It goes on, then it goes off for a second. Then it comes back on, then it goes off for a second. Well, how long has it been doing that? It just started. Does it do that before? No. What's the problem with it?
Maybe it's just fine.
Maybe.
And you never paid attention to it. That's kind of the cycle.
Wouldn't that be normal when it's in the null period?
Yeah, it's normal null period.
Right.
I'm telling you, people say stuff like that. Did you do it before? No, never did it before.
That's fine. We'll take a look at it. We'll get back to you a little bit later.
Yeah, what's that?
That's when you go, okay, we'll take a look at it. We'll get back to you a little bit
I
later.
know, charge you for it.
We look at it for about 5 hours.
That'll be $1,000 and.
Nothing wrong with it.
All right, what else we got here? That was
Does the boot actually is it the boot only being heated, or is it actually heating the prop?
It really only heats the element right here. I'm sure it's too cold to really start running. I mean, it's aluminum and heat transfers well through aluminum. But and when you work on these, like I can see how rusted those are from here. That wouldn't be something I would want to see. It looks like a wire right there is not even connected to that one. What else? So make sure that the wires are connected. Yeah.
When you set it full, or when you override the sequencer,
Uh-huh.
does it wear out the brushes?
What do you think?
Yeah,
Okay. Why?
because of the amp draw and the contact surface.
And what else is it going to do? Arcing,
Yeah.
which is what causes. So the more current you have going through a brush, the more you're going to have wear. All right. Like I said, that was funny once a time, but now it's kind of, everybody's heard that. What is something interesting about the photo?
What's the green thing?
Is that a prop lock?
Prop lock. There's just a big old weight on there that's locked. Start that up. It's going to shake like.
Dog magazine.
Whoa!
Now that is one way to.
Missing something.
That's a supplemental type certificate for a single-bladed Hartzell 2-speed.
Pretty sure that's just a prop lock.
It's another way to do it. You just simply take half your prop with you.
It's easy for restaurants.
Did they
to
ever
think about it.
experiment with just one blade?
Looking at this right here, I'm reasonably confident that it's probably a photoshopped issue. That wouldn't really work, right?
One blade props do work with counterweight.
Uh-huh.
They're the most efficient.
Here it is.
That's not true. They never made a single bladed prop.
Not for real planes.
Well, what's that?
Look at the picture.
Look, yeah.
They did. I know. I believe it was the Germans that first started experimenting with it. Guess what they found out? It is the most efficient propeller made.
Efficient?
Efficient.
Yeah,
It's the most
like when
efficient.
They started building those big windmills for electricity.
Uh-huh.
They're
In
all
the 80s, they actually, and I remember seeing them in Germany, they actually had single props. But then there was too much problem, that's what I read, with bearings and everything, and with the counterweight and everything.
Oh, okay.
So they went to 2 blades, and now they actually went to 3 blades, because that's for longevity, kind of the best.
Okay, the thing I heard about propellers, single blade is the most efficient. It has problems. 2 blade is actually best, no, I'm forgetting this, is best for
Cruise
high speed, and the 3 blade is best for climb.
Right.
Yep.
But why so many blades now? Because they look cool. Tornado coming?
It's a thunderstorm with light rain.
All right,
Do you know why the BMW sign means?
say goodbye.
It's a